Welcomes to Chemistry Exam YouTube channel. In this video, we are going to discuss about characteristics of coordination compounds. Characteristics of coordination compounds. There are 8 points is there in the characteristics of coordination compounds. We will discuss one by one. So, you can listen this video, you will get the idea of characteristics of coordination compounds. So this topic will come either degree exam or some of the competitive exam or school level exams. So everywhere this topic is very important. So please listen. The first point, coordination compound is a compound of a metal with a certain number of species called ligands bound to the metal. So again I am reading, a coordination compound. A coordination compound is a compound of a metal with a certain number of species called ligands bound the metal. So for example, so FeCN6 4 minus. Here Fe is the metal and bound to the means see compound of a metal with a certain number of species. Fe is the metal, Cn is the species. So there are 6 species in the compound, coordination compound. We can write like this, octahedral complex will come. Cn, 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 Cn. So 4 minus. So we can see this is the metal. So a coordination compound is a compound of a metal with a certain number of species. Certain number of species. So certain number of species. So here how many species are there? There are 6. So coordination number here 6 and oxidation state 2 plus in this coordination compound. So a coordination compound is a compound of a metal with a certain number of species called ligands bound the metal. For example, FeCN6 4 minus, the 6 Cn minus, so cyanide groups are called ligands. So this name, IUPAC name, hexacyanoferrate 2 ion, hexacyanoferrate 2 ion. This name, IUPAC name of the coordination compound, hexacyanoferrate ion. So again I am writing the same Fe, Cn, 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 octahedral geometry. Okay. The word ligand means that which binds or gets attached. So in the metal, so cyanide group is attached with metal, that is the ligand. The word ligand means that which binds or get attached. Ligand binds metal, ligands bind metals. In this example, so which one? In this example, the particular example, so the ligand is an anion. So cyanide is the Cn minus is the anion. Many of the ligands are anion. For example, cyanide, chloride, thiocyanide. So Cn minus, Cl minus, SCN minus, Br minus I minus whatever it is, it will come. So these are the anions. Neutral molecules such as H2O water, CO carbonyl, NH3 ammonia, etc. can also behave as ligands. These all are behaves as neutral molecules. It acts as a ligands. An organic molecule such as ethylene diamine, this is the ethylene diamine. So ethane molecule, remove one H, one side and another side one H. So attach NH2, that is the ethylene diamine. So NH2, CH2, CH2, NH2. Or an organic ion such as oxalate ion, COO minus, COO minus, can also function as a ligand. So this is the first point. And normally a positive ion cannot function as a ligand, as the availability of an electron pair of the ligand for binding with the positive metal is the prime requirement for complex formation. A ligand is nucleophilic. So normally positive ion cannot function as a ligand, as the availability of an electron pair on the ligand for binding with the positive metal is the prime requirement for complex formation. A ligand is nucleophilic. So one more time we can discuss the first point. What is the first point? You can remember. So if a coordination compound, so is a coordinate compound of a metal with certain number of species called ligands bound to the metal. That is the first point. For example, this is the example, hexacyanoferrate to iron, FeCN6 4 minus. The 6 cyanide groups are called ligands. This is the octahedral geometry. The word ligand means that which binds or get attached. Ligands bind metals. In the particular example, hexacyanoferrate to iron, the ligand is an anion, which means cyanide. Many of the ligands are anions. For example, Cn minus, Cl minus, SCN minus, Br minus, I minus, etc. Neutral molecules such as H2O, CO, NH3, etc. can also behave as ligand. An organic molecule such as ethylene diamine or an organic ion such as oxalate ion can also function as a ligand. And last one, normally a positive ion cannot function as a ligand, as the availability of an electron pair on the ligand for binding with the positive metal is the prime requirement for complex formation. A ligand is nucleophilic. This is the first point. Next, second point. Second point, what is that? Complex species are of different types. So it's like a cationic, neutral, anionic. Cationic, neutral and anionic. So for example, PT NH3 4 2 plus. This coordination compound is a cationic. And second one, PT NH3 twice Cl2. This is the second one, neutral. And third one, PtCl4 2 minus, anionic. So this one, the second one name diamine dichloroplatinum. Diamine dichloroplatinum. And first one tetraamine platinum 2 ion, and this one platinum tetrachloride. This last one, platinum tetrachloride. So the first one is cationic, second one is neutral, and third one is anionic, which means here platinum 2 plus and here platinum oxidation state 0, and third one platinum oxidation state 2 minus. So that's why this is the cationic, this is the neutral, there is no oxidation state, and third one 2 minus anionic. These are the very important points. Complex species are of different types, cationic, neutral and anionic. Third point, complexation of a metal ion usually increases the stability of the metallic species. Complexation of a metal ion usually increases the stability of the metal species. So thus the complex of the metal ion is more stable than the metal ion itself. So that's why, so more stable, complexation of a metal ion usually increases the stability of the metallic species. The complex of a metal ion is more stable than the metal ion itself. So however, different complexes of a metal have different stabilities. Different complexes of a metal have different stabilities. Fourth point, complex formation is often accompanied by striking changes in color. For example, the complexation of the light yellow aqueous Fe3 with thiocyanate produces a blood red color. So if normally Fe3 a light yellow color, if it's attached with thiocyanate produces a blood red color. That's why complex formation is often accompanied by striking changes in color. This is the main point. And next point, fifth one. So the molecules or ions of complexes have characteristic shapes. The molecules of complexes have characteristic shapes such as like tetrahedral, square planar, octahedral. Tetrahedral we can see tetrahedral complex, nickel tetrachloride, this is tetrahedral, and square planar platinum, so NH3 4 times like tetraamine platinum 2 plus, this is square planar, and octahedral already we have seen what is that, hexacyanoferrate 2 ion. So here 4 minus, this is the octahedral, this is octahedral, and this one square planar, and this one tetrahedral. These are the different. So the molecules of complexes have characteristic shapes such as tetrahedral, square planar, octahedral, etc. depending on the number of ligands bonded to the central metal. Depending on the number of ligands bonded to the central metal. And also one more point, either this is high spin complexes or this is low spin complexes, or this is weak ligand or this is strong ligand, depends on those points. So the shapes will different. Next, sixth point, a complex may be diamagnetic or paramagnetic depending on the type of bonding in it. A complex may be diamagnetic or paramagnetic depending on the type of bonding in it. Diamagnetic contains no unpaired electrons. Diamagnetic substances having tendency to be repelled by magnetic fields. So you can remember. So there is no lone pair present in the complexes. So we can remember that is diamagnetic. Sorry, not lone pair, unpaired electron. Unpaired electron absent, that is diamagnetic. Unpaired electron is present, that is paramagnetic, depending on the type of bonding in itself. See, a compound is a diamagnetic if all its electrons are paired. So paired electron is present, that is diamagnetic. Unpaired electron is present, that is paramagnetic. So that is the main. And next, seventh point. So a metal complex differs from an ordinary salt in some respects. A metal complex differs from an ordinary salt in some respects. When a simple salt such as ferrous sulfate FeSO4 is dissolved in water, it produces its constituent simple ions Fe2 plus and SO4 2 minus. But when a complex compound is dissolved in a solvent, it produces complex ions. So we can remember this point. A metal complex differ from an ordinary salt in some respects. When a simple salt such as ferrous sulfate is dissolved in water, it produces its constituents simple ions Fe2 plus and SO4 2 minus. But when a complex compound is dissolved in a solvent, it produces complex ions. This is the seventh point. And so here example, in this point simple salt FeSO4, it dissolved in water, it produces simple ions, but complex compound is dissolved in a solvent, it produces complex ion. For example, so K4FeCN6 produces, so FeCN6 4 minus on its dissolution in water. The ligands Cn minus attached to the central metal ion are not easily ionized away from the metal ion. So this is the major point. And second one, the species FeCN6 4 minus through containing a metal migrates to the positive electrode, which means anode, when its solution is electrolyzed. So the species FeCN6 4 minus through containing a metal migrates to the positive electrode when its solution is electrolyzed. So the last point. So this is the main point. Some of the metal complexes are soluble in water, whereas some of the others are insoluble. Some of the complexes is soluble in water, some of the complexes are insoluble in water. For example, NH3 twice plus is soluble in water, whereas the complex of nickel 2 with dimethyl glyoxime is insoluble in water. It is soluble in solvent, organic solvents. And some complexes are soluble in organic solvents. For example, bis acetyl acetonato copper 2 is insoluble in water but soluble in organic solvents. Bis acetyl acetonato copper 2 is insoluble in water but soluble in organic solvents. These are the 8 points, characteristics of coordination compounds. So simply I can explain one by one, very simple way. So the first point, what is that? coordination compound is a compound coordination compound is a compound of a metal with a certain number of species called ligands bound to the metal. So here, so anion, neutral species, and what is the last one? Nucleophilic. These are the three is there, three ligands present. So what is that? Negative, neutral, positive. And second point, complex species are different types, cationic, neutral, anionic. So these are the examples of these three types. Third one means complexation of metal ion usually increases stability of the metal species. So which means the complex of the metal ion is more stable than the normal metal ion. And fourth point, complex formation is often accompanied by striking changes in color, which means normal ion in yellow means here Fe3 ion normally light yellow color. If it's attached with thiocyanide, produces a blood red color. Fifth point, the molecules of complexes having characteristic shapes. So I already explained. These are the three examples: tetrahedral, square planar, octahedral, depending on the number of ligands bonded to the central metal or either high spin, low spin complexes. So accordingly. Sixth one, a complex may be diamagnetic or paramagnetic depending on the type of bonding in it, which means electrons is paired, that is diamagnetic, electrons are unpaired, that is paramagnetic. Seventh one, a metal complexes differs from an ordinary salt in some respects. And last one, some of the metal complexes are soluble in water, whereas some of the others are insoluble. And some of the metal complexes are soluble in solvents, organic solvents, or some of the not insoluble. So these are the major characteristics of coordination compounds. If you like this video, please like Chemistry Exam YouTube channel and please subscribe Chemistry Exam YouTube channel, and regularly will come different topics from the subject of chemistry. You will get new videos and you will get benefit from it. Thanks for watching this video.